All right. 3, 11, 22. So what we want to talk about today specifically is zeros. And that is, to be a zero, it's also going to be a factor, okay? Okay, right here.
Thank you, sir.
Give you probably too many. So synthetic substitution is going to be this. We're simply going to plug in an x value. We're going to plug in an x value. And when we plug in an x value, we oftentimes get a y value, correct? So you plug in an x value, then you will get a y value. Now that's nothing new. We know that. You plug in an x value, you get a y value, right? But more specifically in division, it will be the remainder. Okay. Let me go back to what we saw yesterday. And let me get my journal out, see if we can see this. I'm going to show you. Yeah, the trick's coming. It really is. Hope I got the wrong book. My bad. Yeah, I got the wrong book. Okay. Yes, you can. Yes, we're going to use the calculator, actually. Okay. So let me get to where I want to go on this. Okay. Give me a second. Get there. Here we go. This is the notebook I'm looking for. 73. Page 73. Okay, that's what I want. Whisk this way, okay? So, don't do anything, just watch. Just watch. If I were to plug in 3 into here, 3 squared plus 6 times 3 plus 12. And I'll show you. We can do that. I'm going to grab a good calculator. I want to do this. So if I plug in 3, I will get an answer of 39. Okay, listen to what I'm saying. If I plug in 3, I'm going to get 39. I will. I'm going to go 3 squared plus 6 times 3 plus 12, and I get 39. Okay? So what we know is this. So if you plug in an x value, you get a y value. But that is the remainder. I plugged in an x value, I got a y value. But that was the remainder of what I divided in that problem, okay? So you get the remainder. So synthetic substitution is simply this. You plug in an x value, whatever you get as an answer is the remainder, okay? Why is that important? Well, the factor theorem is like this. Example. Are you listening? Example. 4 divided into 20 is what? 5. Does 4 go into 20 evenly? Is there a remainder? So we could say, in a sense, the remainder is 0. Everybody agree with that? If the remainder is 0, it's a factor. It goes in evenly. Okay, does that make sense? If we do our division, like in our notes, right, and we divide, and it goes in evenly, then it's a factor. So the factor theorem is this. If p of x is divided by q of x. Okay, so if I got a polynomial, divide by something else, and the remainder is 0, the remainder is 0, then q of x is a factor. Now, being a factor is really important because it goes in evenly. Being a factor is really important. 5 is a factor, right? 4 goes into 25 times. There's no remainder. Because I would say, what times what makes 20? You wouldn't say out of 21. So if we can divide evenly, we'd get a remainder of 0. That means that would be a factor. Okay? And that becomes really important next week. So, example 1. Is x minus 2 a factor of 4x squared minus 4x minus 1? Well, there's 3 ways to do this. There's 3 ways to do this. And I'm not going to, I just want you to watch. Don't write this down. Don't write this down. 3 ways to do this. 1, I could go x minus 2 into 4x cubed squared minus 4x plus 1. And I could divide it. I could divide it and look for my remainder. I'm not going to do this. It's the long way. X goes to 4x, 4 times 4x squared, minus 8x, subtract, blah, blah, blah. If I get a remainder of 0, it's a factor. This is the hard way to do it. We don't really care about the answer. We only need one thing. Is it a factor? Well, if I plug in x minus 2 equals 0. Or if I plug in 2. Okay? So if x minus 2 is a factor, then x minus 2 equals 0 would be a factor, which means x equals 2. So I took the opposite of this. I took the opposite of this value. Okay? And I'm going to plug it in. So I'm going to go p of 2 is 4 times 2 squared minus 4 times 2 plus 1. And I'll stop and slow down because I really want you to understand what I'm saying. Huge concept, okay? So, if x minus 2 goes in evenly, we could divide it, okay? I could divide it and find out the remainder. My remainder theorem, or my synthetic substitution, says if I plug it in, I'll get the remainder. If I plug it in, I get the remainder. So let's plug it in. Okay, that's going to be 4 times 4 is 16 minus 8. Let's see what I get, okay? So I would get 4 times 4 minus 8 plus 1, 16 minus 8. So it is not. In fact, I think I get 7, don't I? 16 minus 8 is 8 plus, oh, I get 9. It's not. So x minus 2 does not go in evenly. It is not.
Why is 9 not a factor?
A factor. Oh, you asked the best question. It must have an answer of 0. Must be 0. 0 is what I want. If it's not 0, it just doesn't, it has a remainder. Okay, I'll say it again. Any number except for 0 is a remainder. So this one would have a remainder of 9.
So factors have no remainder?
Yes, say that again. Yeah, check it out. Is 5 a factor of 20? Why? There's no remainder. It goes evenly, right? So Cassie, same thing. Factors will have no remainder. So if I get an answer of 9, 9 is a remainder. Okay? So now, let's divide it. So if I really go x minus 2 into 4x squared minus 4x plus 1, I'm just going to divide it. X goes into 4x. 4x times. I multiply. I get a 4x squared minus an 8x. I subtract, so I have to subtract a negative. I'll get a 4x. Bring down my plus 1. X goes to 4x 4 times. I multiply. 4 times 4 is 4x. 4 times a negative 2 is a negative 8. I'm subtracting, so I subtract. I change the negatives. Guess what my remainder is? 9. So the question really doesn't say this question doesn't really say, it just wants to know if it's a factor, right? I didn't really have to divide it to answer that question, right? I just plugged it in, I got an answer other than 0. It's not, it has a remainder of 9, okay? Synthetic substitution tells you the remainder, okay? One more time. Synthetic substitution tells you the remainder, okay? Let's see. Say, okay, tells you the remainder, okay? Synthetic substitution tells you the remainder. And the remainder is important because I might say, is it a factor? Well, if you can get the remainder without dividing, that's pretty slick, isn't it, right? Okay, now turn the page. What about synthetic division? So we can divide. It's a really cool way to do division, but it only works with x plus or minus some value. We're not going to have to do this long, ugly division if it's just x plus or minus some number. If it's x plus or some number, we won't have to do this. Unfortunately, this problem we have to do the long division. Okay? It only works on problems like this. Okay? So it's x plus 3. Synthetic division will work. Okay? Now, I'm going to go slowly. All right. When you do synthetic division, the x's are invisible. Okay? All my x's are invisible. Okay? Everybody with me? Gabe, put that phone away. All my x's are invisible. Okay? And because it's a weird division, I'm going to do this. Upside down division. Upside down division. Okay? Just make an upside down division sign. Start right there. Okay? Up. Okay? Upside down division. And take the opposite of this. So I'm going to go -3. And the reason we do that is because we are really adding a negative. You saw me change the signs, right? Whenever I subtracted, what I do? I just basically change the signs. It's the same thing. We change it right at the bat. So do the opposite, okay? Now, x's are invisible, right? 4, -2, 1, -3, 4. So the x's are invisible, okay? Are you all right with that? So I did 3 things so far. Upside down division sign. I did the opposite of what I'm dividing by. And my x's are invisible, okay?
So the x's and the exponents?
Everything's invisible except for the coefficients, yes. Now we know the x's are there, okay? Does that make sense? So now I put what I call, this is called my add line. And I'm going to put a box right here, and that's where my remainder goes, which is right under my constant. My box is all the way under my constant, always, okay? So here's my constant 4. My box is here, and that's where my remainder goes, okay? Now this is weird. You've never seen this before, right? All right, you ready to do it? Here. And it may seem complicated, but once you get the hang of this, it's a lot easier. Step 1. Bring down the first term. And I like to put an arrow in there so nothing goes in there. I like an arrow because I don't want anything to go in that spot. Bring the first term down. Okay? Bring first term down. Okay? Then we're going to multiply. 4 times -3 is a -12. I put it in the adder line. Put it in here. So I'm going to put a -12 in here. That's called the add line, right? Isn't it called the add line? So we're going to add. We get -14. Yes, so this is the multiply. So 4 times -3 is -12. It's on the add line, isn't it? It's on the add line, so we add. -2, -12 makes -14, okay? How am I doing, okay? Now, we're going to multiply. We're going to multiply. So I'm going to go 14 times, -14 times -3 is, what's that, a 42. I think it's 42, right? Positive 42. I think it's positive 42.
And then do you add the 1?
Yeah, I'm on the add line, so add them, and I get a 43, okay? Then we multiply, and I might need a calculator to multiply. Let's see, that's going to be, what's 43 times 3? 43 times 3 is 129. Yes. And it's on the add line, so I add, and what's that, negative 132. And then I multiply. What's 132 times 3? 396. And then I add, and my answer is going to be, that's a 400, right? That's a big remainder. So the first thing I know is this. Before I go any further, I know this. X plus 3 does not go into this polynomial evenly, because we have a remainder. It's a bigger remainder. Katie, question? And we don't have our answer. Our answer is here. But
So we just know the remainder?
this is our answer, but our x's were invisible, right? Okay. So we invisibly divide by an x, so instead of x to the fourth, we invisibly divide by an x, so that's the next fourth, this is going to be an x.
And this is called
third.
synthetic division.
This is synthetic division. So what we're going to, I'll show you, we'll do a couple of these to make sure you guys get it. So my answer, for my answer, is a 4x cubed minus 14x squared plus 43x minus 132 plus 400 over, just like it was before, 400 over. What did we really divide by? X plus 3. Now it's weird, but it's a lot faster.
How did you get the 4x cubed? and
Great question.
4x squared?
So Cassie, let's go back to the very beginning.
Can I go to that?
Yeah. We made our x's invisible, didn't we? So all of these numbers had invisible x's, didn't we? So the x's are still part of the problem. So the answer is all about x's, right? And we invisibly divide an x into an x to the fourth, which should make it an x cubed, right? So my answer is, I gotta bring back the
There has
x's.
to be one less.
Yes, it has to be one less. Yes. Does that make sense?
Wait, this makes more sense than like the other one.
Oh, gosh, yeah. If you know the trick, it's easy. Now, we could do it the long way and get the same answer, right? The x goes to 4x cubed. We do long division like we did before. Get the same answer.
What happens if Pascal's triangle?
Well, that's going to be on
Are
our
we
test
coming
too.
back to
Oh,
that?
yeah. Of course, yes. Now, let's take a look at number 4. But before we do number 4,
Wait, we get the same answer using the triangle thing?
no.
It is different.
This is different. No triangle. Okay, before we do example 4, look at these two numbers.
I'm missing a 0.
Yes. So if I divided this, there's a totally different number, agree? I am missing what?
Oh.
And I have to have that number, just like I have to have the 0. Does that make sense? So it really has right in here like a 0x to the fourth. You have to have that 0, don't you? It's a place value. So let's do synthetic division again. So what's the first thing we have to do synthetic division? Okay, opposite, so I'll put a positive 2 here. Good. Then what? Upside down division. Good. Then what?
Forget about the x's and write the numbers.
5, 0, right? Gotta have a 0. 3, 4, negative 4, 1. Good, 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 good. Now what should we do?
Bring down the first term.
Not yet. Yes, but not yet.
Add your add log.
We need my add line. We need my add line. And then last, what we have to do is to
Remainder box.
make our remainder box. Okay, there's my remainder. Now, Cassidy, what did you say? Okay, so we bring down the first term. And I like to occupy the space because I don't want to put anything in there. You guys agree? So bring down the first term, put a 5. And then what do? Yeah, multiply. We get a 10. And then? And 0 plus 10 is 10. And then what? Multiply, and we get 20. Then what? 3 plus 20 is 23. And then what? 2 times 23 is a 46. And then what? And I get a 50. And then what? I get a 100. And then I get a 96. And then what? Multiply. Oh, what's that? 192? I think so. 192. And then add. So I know one thing, it's not a factor because the remainder is not 0, right? It does not go in evenly. If the remainder is 0, I'd be happy, but it's not. So what's our answer? It's like Cassie says, 1 less power. So the answer's got to be 1 less power. 1 less power is totally correct.
Why do you use 1 less power?
Well, because I'm dividing really invisibly by x, aren't I?
Oh,
And if I divide x into x to the 5th,
oh, gotcha.
it makes x to the 4th, right? So then my answer is 5x to the 4th plus 10x cubed plus 23x squared plus 50x plus 96 plus my remainder, right? But I got to bring back in the x's. X's have to come back in, so plus 193 by what I divided by invisibly. I really divided by an x minus 2. That is the answer, and that's a lot easier than doing that. Do you agree?
Yeah.
A lot easier. Okay, so what I have for homework for us today, you guys, is
Can I use this method on yesterday's homework?
not all of it. That's a great question, because you can on the first problem, but a lot of them you can't, because it has to be just x plus a number, x or plus minus a number only. But you certainly can on the first one, and it'll work on the first one.